Assalamualaikum warahmatullahi wabarakatuh. My name is Roshada Binti Muhammad Ariffin. Today I would like to present my final year project, which is Transformer Partial Discharge Detection by Patch Antenna Method. Okay, first I will start with the introduction. First is project background. Power transformer is used in an electrical network to provide several AC supplies with different voltage and corresponding currents value from the public electricity supplies. A survey conducted by a secret working group on failure in large sample of transformer found that 53% were due to mechanical failures. So compared with the conventional device such as winding machine, a few diagnostic methods have been suggested for the power transformer. So there are 4 types of diagnostic method, which is partial discharge detection, dissolved gas analysis, frequency analysis response, and vibration analysis method. Next is problem statement. The power transformer are very expensive and the failure of this transformer may result in the disruption of the power supply to the industry. So it is important to prevent the transformer from the total disruption. Then is objective for this project. So there are three main objectives, which is first is to investigate partial discharge phenomena in power transformer. Second is to perform measurement on partial discharge on transformer during online condition using a patch antenna. And the third is to analyze the partial discharge signal emitted by the transformer measured using the antenna. Okay, next is project scope. Okay, the first scope is investigating the characteristic of PD in distribution transformer. Second is the antenna is suitable for detecting PD signal that travel through the air from the dry type transformer. Third is the study will be applied on the 11/0.415 kV dry type distribution transformer in one of the UTHM electrical substation. Fourth is 2 units of distribution transformer were tested. Fifth is using 2 different types of ultra-wideband antenna. Sixth is measurements were performed on all phases of HV winding only because LV winding does not produce PD. 7 is comparison signal between phases and transformer were conducted. Okay, second is literature review. Partial discharge in transformer. According to the IEC 60270, PD's concept is localized dielectric discharge under high voltage feed stress in a partial area of a solid or liquid electrical dielectric insulation. The discharge occurs when a localized electrical feed becomes more critical than the area of the breakdown voltage. So, with a void, crack, foreign material or structural imperfection being present, this may happen. Depending on their frequency in a specific setup, the PD is split into 2 main subgroups, which is internal and external PD. So for the internal PD, there are 2 types, which is void discharge and electrical drain. For the external PD, there are corona and surface discharge. Next is technique of PD detection. So, the method for PD analysis must be complied with IEC 60270, the international standard for calculating electrical discharge in isolation. IEC 60270 indicates that PD measurement is applicable to the measurement of PD which occurs in electrical apparatus, system and components when tested with DC or AC voltage up to 400 Hz. So there are several methods of PD analysis method. The first one is electromagnetic detection method. Second is electrical detection method, and the third one is acoustic emission method. But for this project, we only focus on the electromagnetic detection method. Then is PD pulse charge. The value of the pulse charge is obtained by calculating the area under the curve. The area under the curve is calculated by dividing it into several segments, and each segment is calculated by multiplying the value of height and width. The value of the height is selected from the average of the height of each segment. Each segment area is added to obtain the area under the curve, which is equal to the PD pulse charge value. Okay, next I will explain the methodology of this project. First is patch antenna sensor. The preferred antenna for the transformer PD detection by patch antenna method is an ultra-wideband printed antenna. This antenna has a 350 MHz to 1.5 GHz spectrum that translates to around 1 nanosecond pulse. This antenna is built in on 1.6 mm thick FR4 PCB substrates with a relative dielectric constant of 4.4. This antenna also has a quicker response time, and this will ultimately give good prospect in the PD locating system capabilities with 2 to 3 GHz input bandwidth, as the ADC is 3 gigasample per second for each input of this sensor. So this is the figure of the sensor that we'll use, which is classified as sensor 1 and sensor 2. Okay, next is parameter of sensor 1. So this is the parameter of the sensor 1. This sensor has dimension of 24 cm times 20 cm. Second is the parameter for the sensor 2. So the sensor has the dimension of 27.5 cm times 18 cm. Next is location of the test site, which is where the dry-type transformer is located. So it is located near the FCAT building, which is in the PE23 block M2. Okay, next is the process of measurement. So the first is we start to perform the patch antenna method. After that, we setting up the equipment for the measuring process. We use SMA female cable to connect the patch antenna sensor with a data processor, which is oscilloscope. Then we place the patch antenna sensor near the dry-type cast resin to perform the measurement. So this measuring consists of sensor 1 and sensor 2. So then, the measurement start with place the sensor on the phase R. If the sensor detect the partial signal, then save the measurement data and then proceed to place the sensor on the phase Y and phase B. So if the sensor detect the PD data, we can save the measurement data and end the measuring process. So this is the experimental configuration that how we conduct the measuring of the PD detection. Okay, next is result and discussion. So the PD detection will measure signal in time domain on TS1. So this is the result for the PD measurement on the TS1. So the first row is the result for the sensor 1, while the second row shows the result for the sensor 2. Okay, so from this graph, then we convert it into the PD pulse charge, which is by calculating the area under the curve. So this calculation were done by using a MATLAB simulation. So based on the table, sensor 1 shows that phase B pulse charge is the highest one with the value of 677.55 nanocoulomb, followed by phase R and Y with the value of 485.81 nanocoulomb and 456.67 nanocoulomb respectively. As for the sensor 2, it is shown that the pulse charge on the phase Y is the highest with the value of 676.4 nanocoulomb, followed by phase B and R with the value of 545.327 nanocoulomb and 526.4 nanocoulomb each. So next is the measure signal in time domain on the TS2. So the result for the first row shows the result for the sensor 1, while the second row is the result for the sensor 2. So by calculate the area under the curve, we get the value of the pulse charge on the TS2, which is also by calculate by using a MATLAB simulation. So Based on the table, sensor 1 shows that the phase Y has the highest pulse charge with the value of 584.52 nanocoulomb, followed by the phase B and R, which is 427.01 nanocoulomb and 336.46 nanocoulomb respectively. As for the sensor 2, it is shown that the pulse charge on the phase Y is the highest with the value of 417.84 nanocoulomb, followed by phase B and R with the value of 430.46 nanocoulomb and 455 nanocoulomb each. So, based on both sensors, the result shown, it is shown that the pulse charge on phase Y is the highest one, followed by phase B and R. According to that, it is means that the phase Y has the highest presence of PD compared to the phase B and R. Okay, then is conclusion and recommendation. As for the conclusion, we can conclude that all of the objective is successfully achieved. So first is we successfully investigate partial discharge phenomena in power transformer. Second, we successful to perform the measurement of PD on transformer using online condition using a patch antenna. And the third one is we successful to analyze the partial discharge signal emitted by the transformer measured using the antenna. So as for the outcome of this study, for the transformer 1, sensor 1, phase B pulse charge is the highest one, followed by phase R and Y. As for the sensor 2, the pulse charge on phase Y is highest, followed by phase B and R. Next is for transformer 2 and sensor 1. Phase Y has the highest pulse charge, followed by phase B and R. For the sensor 2, the pulse charge on phase Y is the highest, followed by phase B and R. So we can conclude that the pulse charge, the result indicates that transformer 1 has the highest PD concentration compared to transformer 2. Okay, then is recommendation. For the further research on the transformer partial discharge detection, one sensor is used only and measured on several dry-type transformer in UTHM, which aiming to explain the PD signal concentration on different transformer. As for the future works, it is recommended for the industry to use the patch antenna method to detect the partial discharge phenomena, as it is one of the preventive techniques. This method can perform during the online condition and as early detection of transformer fault to prevent the transformer from the total damage. Okay, that's all from me. Thank you.